All right, so we are in Algebra 1, and my tablet is unplugged. Darn. All right, today's date is Wednesday, January 22nd, 2020. Make sure your name and date are on your paper. And this is now plugged in. So 1/22/20. Who wants to read our objective? Looks like Emma had it first.
Use multiple properties of exponents to find equivalent statements.
Yes, and then just kind of, thank you, as a review of what a statement is, it's something that doesn't have an equal sign. So notice that in example 1 and 2, there's no equal to sign, which means it's just some fact, some math number. And you're going to be using multiple properties from yesterday. So, example number 1, we have to find expressions that are equivalent to this guy. And we're choosing all answers that apply, which means it could be A and B, it could be just A, it could be just C. Can't be A, B, and C, that doesn't make sense. Someone talk to me about this problem. You got your card still, Charles? Yeah, go for it, Charles.
So you would multiply the bottom, I don't remember what it's called, base, and add the exponent whole power. So it should be -6/18.
It should be -6/18. How'd you get the -6? I see the 18 is...
Add the exponents.
Okay, so the exponent is -6, and then you had 18 on the bottom?
Yeah.
For the base, so 18 to the power of -6. All right, you have to be careful here. So remember that our rules of exponents yesterday only apply to numbers that have the same base. So if this is 3 and this is 3, then I have unlocked the power to add their exponents. But since they're different bases, I can't use that power. That's a great thing to talk about, so thank you. We'll give it to another student, but if you think you have the answer, go ahead and circle it and we can come back. Kira.
I think it's A because, like the bases aren't the same. Oh. No, I still think it's A.
All right.
Even though the bases aren't the same. Like,
Why do you think it's A?
I think it's C.
Oh, why do I think it's
Yeah, why do you think it's A?
A? Because, well, -3 plus -3 is -6. And I think you're still going to be multiplying the 3 and the 6, but you combine the exponents.
Okay. So you're close, but A is actually not an answer. I want someone to see if they can explain why A is not an answer. Who has their card still? Wyatt.
I think A is not an answer because it really is showing kind of what Charles was thinking, because if you do the parentheses, 3 times 6 is 18 to the -6th power. So, and if you just distribute the -6 power into the 3 times 6, it'd be 3 to the -6 power times 6 to the -6 power, which is not the same equation as 3 to the -3 power.
Okay. Yeah, and that's a good explanation. Charles, do you want to explain it further? Or do you want to do another? Okay, well, you're going to be next for B unless there's someone else that has a card. But let me rewrite this another way. So I want everyone to write this down in our notes. So this is actually going backwards with a property that we learned yesterday. So the property that we learned yesterday is if I have something in parentheses, 3 times 6 or x times y, and all that is to the power of -3, I can distribute that -3 into both of these two terms, and it can turn back into what I started with. So this is kind of going backwards. It's kind of like the factoring rule if I'm going backwards, I suppose. But this would have been correct. If this -6 turned into a -3, then we would have had the right answer. But we don't add them, we just factor out the -3s. And then I leave it 3 to the power of 1 and 6 to the power of 1. Any questions about that explanation? Otherwise, we're going to move on to talking about B. All right.
So
Oh, yeah, question here?
you divided 3 by 3 and 6 by 3?
The -3, are you talking about the exponents or the bases?
Well, you just said, like, you factor it out and then you end up with, like, 1 and 2 or something.
Yeah, you factor out the power. So if I pull away this -3 and pull away this -3, because they're the same power, I can pull them both out onto the outside, and whenever I divide -3 by -3, I'm left with a 1, and whenever I have a 1, I just leave it as 3. I can say that 3 or 3 to the power of 1. Either way is the same
But
answer.
why did you divide 3 by 3?
I'm just showing you that I can go backwards. So if these are both the same power, you can pull them both to the outside. I guess I can pull back up the notes from yesterday. Give me a sec. I can show us the rule that I'm talking about. Algebra 1, it's going to be that 1. It's 12, 1. So it's this rule right here. This x times y to the power of n. Instead, now we're starting right here, and then we're going to the left instead of starting on the left and going to the right. So I have the same power, and I factor that power out. And that's what I'm saying back over here. I have the same power, and I'm factoring that power out.
That's just the simplest form.
It's a different form. I wouldn't say either one is more simple than the other, but you should know that they are equivalent forms. Yeah, what?
So what you're saying there is 3 times 6 is all to the power of -3.
Yes.
So if 3 times 6 is in parentheses, could you multiply that together, get 18, put it to the power of -3, and then put the 1 above it as a numerator, and your answer would be b if 1 above 18 to the 3rd?
Yes.
Oh.
Well, why would it be negative though? Because wouldn't it be positive?
After he flips it to the denominator, is that the question, Emma?
Yeah, because
It would be positive, exactly. Yeah, and that means that it is indeed b. Yeah, Charles, did you want to explain it your way?
No, that's fine.
Okay. So again, I'm going to go through Wyatt's steps right now. So he's saying, okay, now I'm kind of simplifying this. I see 3 times 6, and according to PEMDAS, I'm going to do parentheses first. Dealing with the parentheses, I have 3 times 6, which is 18. This is now 18 to the power of -3, and everyone will write that down. 18 to the -3. Oh, but there's another rule that I can use. And if you remember back from yesterday's notes, when I have negative powers, let's come back over here, negative powers, like this one, I can flip it, so this flips upside down, and then this negative becomes a positive. So if I come back here, this is really 18 to the -3 over 1, because I can put anything over 1, it's still its same number. And then now I'm going to flip it. I'm going to take the reciprocal. So this is now 1 over 18. And instead of a -3, it's now going to become a +3. And that's exactly what B looks like. So the answer here is not A, but just B.
what's Mr. Sindel? Is the exponent positive after you put 1 over 18 to the 3rd power?
Yeah, so you're asking, is this number supposed to be positive?
Yeah.
Yeah, it is. Exactly. And it has to be positive whenever I take the reciprocal.
Okay.
And every time that you take the reciprocal, just know that you're multiplying the power by -1, which means if I had a positive number and I wanted it in the denominator, I could flip it and it would become a negative power in the denominator. Are there questions about number 1? All right, then we're going on to number 2. Oh, yeah, question. Oh, you want to do number 2? Well, you're definitely my backup, my first backup, unless there's someone else with a card. All right, so number 2, which expressions are equivalent to that guy? Ooh. All right, well, now we have the same bases, so we've unlocked every single property of exponents. So you can go wild here. Is there anyone that has a card? Yeah, Larissa.
I don't really know, but maybe first you'd have to distribute the 2 into everything.
Okay, let's try it, yeah.
Top.
So tell me what to write.
3 to the 6, and then 3 to the 8.
That is a perfect first step, yeah. And you didn't have to do this first step. There's a lot of different ways to solve this one. If you found a different way, that's awesome. All right. Larissa, did you want to keep going, or did you want to hand it off to someone else?
Somebody else can pick.
Okay, you can call on them.
Emma.
You would multiply the bases, right? Because they're the same.
So if I have the same bases, then I've unlocked the rules of exponents. So now anything on this left-hand side is free game. And specifically, the one that has a multiplication sign is probably going to be the one that we use. Yeah, so what do you see that you could do there, Emma?
Add the exponents.
Okay, so what would I write here?
14?
Yeah, 3 to the power of
To the-
14.
Yeah, 3 to the 14th power.
Perfect, yeah. So that's another way of writing this expression right here. Questions? Yeah, Kira.
I was just gonna say, you could get the same answer by adding 3 plus 4 and then multiplying 7 times 2.
Perfect. Yeah. So the other way of doing it is by first doing this. I'm going to add the exponents, 3 and 4, 3 to the power of 7, as Kira said. 3 to the power of, that's backwards. 3 to the power of 7, and then this is still to the power of 2, and you said you multiplied those, right? Yeah, and then you multiply those and you get 3 to the power of 14. You still get the same answer 2 different ways. That's awesome. Yeah, thank you. I had a question from Esha too that I saw.
Well, so since it's 3 times 3, couldn't we multiply that or no?
Yeah.
So
I mean,
yes, if you're using a different exponent, but generally speaking, whenever you have the same base, you want to use your rules. And because I think the question is, should this be 9 to the power of 14? Should the answer be B? Is that kind of the line of reasoning?
yeah, sort of.
So whenever you have rules of exponents, whenever you have the same base, you never multiply the same base unless you're factoring them out. If I could factor them back out, then I'm going like backwards a step. I'm essentially going back, back to this step. So if you ever want to multiply the bases, you'd have to have different bases and then factoring them out. So it's a little bit hard to do. So use your rules of exponents. Whenever I have the same base, just add the exponents. Whenever you have the same base, just do the rules of exponents. There's how many of them? 7. So the answer is no. Don't multiply it in general.
Okay.
So then what would our answer be?
That is a great question. We don't know yet. Jade, did you solve your question?
That was my question.
Oh, okay. Why you don't have your? Oh, I thought you were gonna raise a card. Eamon, yeah, go for it.
I would say that the answer would possibly. I see B as being right, but I also see A as being right as well.
Could you simplify A for us? This could be turned into something, right, Eamon?
A is what happens when you multiply the 3 over 3 by the 3 over 3 exponent 4, which will equal 9 exponent 7. But it's still in parentheses with the exponent 2.
So you have to be careful there. Whenever I multiply these two together, it actually turns into 3 to the power of 7 instead of 9 to the power of 7. But what would you do, Eamon, if I had 9 to the power of 7, I started with 9 to the power of 7, and I took it to the power of 2? What would I do with 7 and 2? Do I add them or do I multiply them?
It would be turned into a 9 over 14.
Exactly, yeah. So these are actually the same answer, 9 to the power of 14. Yeah, thank you. Wyatt?
Can I say what I think the answer is?
Sure.
I think it's C because our answer in the most simplified form is 3 to the 14th, and those are saying 9 to the 14th. I think that their mistake was multiplying the bases together, so they made that mistake. So I'm thinking that C is the answer for them.
And you are correct, and that's exactly what this question is getting at. It's trying to tell students, hey, make sure you don't ever accidentally multiply your bases. You're only keeping the same base and then applying rules of exponents to it. So the answer isn't A, it's not B. Those are common mistakes. The answer is actually C. Gotcha.
But if they're different bases, you multiply them.
If they're different bases, then you can't use rules of exponents. You have to do tricks in order to be able to do things. So for example, if I had, say, 2 to the power of 3 times 3 to the power of 7. Like, what would I do? And the answer is there's nothing that you can do. You can't say, oh, I'm going to change this to 6 to the power of, and I add 3 plus 7 to 10. That's not how it works. I have to have the same basis in order to add anything. And if I don't have the same basis, I'm kind of gridlocked into doing nothing, unless there's special tricks. And I'll teach you those tricks eventually in Algebra 2. But for Algebra 1, I'm just strictly saying, what are your rules of exponents? Can you apply them? So very, very important. Look for same bases. When you do have the same bases, you'll use rules of exponents. Don't multiply the bases.
So when a problem is like that, you can't do anything.
So when a problem is like that, there are kind of high-level tricks that you can do, but nothing that I'm going to be teaching in Algebra 1.
Is there a code assignment?
Ooh, I did not put it up today. All right, let me go put up the assignment.